You need almost no integrated tests at all. 99.5% of your tests can be micro tests that run entirely in memory. The old phrase is test until fear transforms into boredom. Deleting tests is always safe. If there's tests getting in the way of your refactoring, throw them away. One thing that every junior programmer needs to do as soon as possible is miss a deadline. The presence of the impatient customer is the only reason that you can call what you're doing a business. Right. If you don't have an impatient customer, that's called a hobby.
Hi and welcome, folks, to a new episode of The Marco Show. Today we're going to be talking about a topic which I guess people will still be debating in 50 years, even with the advent of AI. We're going to be talking about testing, from integration testing, unit testing, acceptance testing, contract testing, everything there is about testing. And a while ago, I think it must have been already a decade ago, I watched a talk which was called Integrated Tests Are a Scam. And there's a new talk which is, kind of integrated tests are a scam revisited. I also watched that talk and I thought, we could just invite the person who gave these two talks so we can talk a bit about testing and why integrated tests are a scam or have been a scam or maybe it changed. So hi, welcome, and who are you?
Hi, I'm JB Rainsberger. Some people call me J-Brains and get me confused with JetBrains. And so actually that's one thing I'd like to settle first.
Yes.
I was forced to choose an 8-character username at IBM in 1997.
1997?
And I shortened my name to JBRAINS because it didn't make sense to add the B. And my manager said, "Oh, J-Brains, cute." And that's what I was from that day forward. So did I beat JetBrains?
I think you actually did. I think
yes.
I think you did by just a couple of maybe years.
Excellent.
And also our first tool was called Rename. And I'm not entirely sure if at that point in time we were already called JetBrains. I don't know, but I need to figure it out.
Because I still get about one person a month who keeps thanking me for RubyMine or asking me about trying to get some JetBrains support or something.
Does it happen? People actually
it does. And in fact, if you put JBrains into any of the search engines, they assume you mean JetBrains unless you put quotation marks to say I'm serious.
Well, that's very cool. But it's also good marketing for you, I guess.
Well, yes and no, I suppose. It depends on how people... I don't know whether that means that I'm losing traffic or gaining credibility. I guess it's probably a little bit of both.
Right, a little bit of both. Right, so then back to testing. How do you get into testing, and how did that talk, integrated tests are a scam, actually come about?
So I started working professionally at IBM in Toronto in 1997, and pretty soon it became clear that I didn't know how to write code without making mistakes. So I kind of struggled for a year or two. And finally, I had this experience of working with testers, and it felt very adversarial, as it probably still does today, where, the job of the tester is to tell you how wrong you are. Mm-hmm. And it was a little more formalized back then. So that meant that those discussions could get maybe a little bit heated, maybe a little bit tense, and certainly a little bit embarrassing. Like here I am, 25 years old. I feel like I have been working towards this career my entire life. I said at the age of 12 I wanted to work at IBM, and I'm not doing it. So I was trying to figure out what was going on. So I did the only thing that made sense at the time. I opened up Netscape Navigator, and I went to altavista.com, and I typed in the phrase, how to test Java code.
Right, that's what you typed in.
And I found this thing called JUnit. So I started reading about it and thought, this is kind of interesting. And then I stumbled upon a draft of the book Extreme Programming Installed by Ron and Chet and Ann. I still joke to Ron to this day that I've never paid for his book because I read an early draft, so I never actually had to buy it. So sorry about that. But that was the point at which I became acquainted with this idea of programmers doing their own testing. And then that's also what got me involved in the extreme programming community. And by 2000, 2001, I was going to conferences and writing more about what we called back then programmer testing. And 25 years later, I'm here. So that became the big first phase of my career, which was focusing on, I guess, how do programmers take more responsibility for the correctness of their code? Mm-hmm. That was sort of the first thing that interested me. And of course, like anything else, when you coach people, you're almost always coaching them in something that you need yourself.
Right.
That's the reason that you then start coaching others. It worked for me. Now I'm going to help other people with it. And so that's what it really was for me. I was tired of showing code to testers that didn't work. I wanted to be the person that they trusted, not the person that they had to watch over. And that was how it started. And from there, it went on to test-driven development and evolutionary design and getting into more of the social aspects of what happens when people try to do this stuff together. Mm-hmm. And, I'll still teach test-driven development for money, but a lot of what I talk about now is more in the what happens when we try to do this stuff together and what are the problems and all that kind of stuff.
And we'll get into that.
Yeah.
We'll get into that. So people who are interested, you can actually watch your talks on YouTube, and if you just search for integrated tests or a scam, you'll find plenty of recordings.
Unfortunately, yes. Yeah.
Yes, but I wanted to get into terms first of all.
Sure.
To get everyone aligned, so to speak.
Yeah.
So what exactly counts as an integrated test for you, and how is it different from an end-to-end test, for example? Right. How would I define that?
Exactly is a little bit hard. So there's a bunch of terms related to the kinds of tests that we programmers write to give ourselves and each other confidence that our code does what we wanted, or at least what we tried to do. So that's that whole programmer testing thing. So everything that I'm talking about now is a programmer test, as opposed to the test that gives the customer the warm, fuzzy feeling that we understood them. And so there's lots of terms, and they're all really confusing, and different people mean different things by them. So all I can talk about is here's what I mean when I say these things. And for me, end-to-end test is usually pretty straightforward, even though most people, when they say end-to-end test, don't actually mean quite end-to-end, because end-to-end is always a little farther than you think it will be. But usually it's like the beginning of our running system all the way to the end and back. And so that's the biggest kind of integrated system or integrated test. And then you have a unit test, which is like a test intended to check a smaller, independently inspectable part of the system. But smaller is kind of where things get a bit murky. That's why we have terms like micro test when we really want to emphasize tiny, maybe one function or a very small cluster of functions at a time. And then an integrated test is pretty much any test where the amount of the system that you run is, let's say, significantly bigger than the part that you're actually trying to check. So if you're trying to zoom in on this thing and see if this works, but you have to run something 2 or 3 or 12 or 15 layers bigger, that's kind of what I meant by integrated test in the first place, and why I switched about 15 years ago to calling them integrated tests, because a lot of people call them integration tests. I want to see if the pieces talk to each other. But part of the whole point of what we're going to talk about today, is, spoiler, that maybe it's not wise to run large parts of the system when you want to check integration. Maybe just focus in on the point where you're actually integrating between two things. I know that we'll probably come to that before too long. And so when I switched from the term, I wrote integration tests are a scam is a scam. When I wanted to exactly the self-referential stuff is, I love that kind of humor. It's a part of the extreme programming community. To rename it to integrated test to emphasize that the problem wasn't that I'm trying to check the integration points. The problem happens when I want to check this little thing and I run this big thing. And then when that test fails, we have no idea where the problem lies. And so integrated in the sense that we've run bigger pieces of the system integrated together, even if we only want to check this little thing. And so then for a unit test, I don't know, how big a unit do you want? I mean, a unit can be anything big or small that can be independently inspected from the rest. So now we don't have to argue anymore about whether this is a unit test or not. If it can be independently inspected, then it's a unit test. I don't care if it's this small or this big. But an integrated test is bigger than it needs to be. It's certainly not a micro test, but it could be end-to-end. You can see why people get confused, why we end up with all kinds of pointless arguments.
Right.
And the only good news is that that means more time for consultants to bill.
Right. Just to get a bit more specific again once more on that. So I think your stack has been Java. I mean, have you been in
Java's still kind of my, let's call it my primary native language.
Right. Okay. So let's say I have some sort of web application. I have a Spring Boot application.
Okay.
That Spring Boot application talks to a Postgres database. It maybe, I don't know, talks to Kafka. Maybe there's a couple of REST APIs I have to integrate with.
Starting to sound complicated already.
Yes. So, I mean, a couple of things kind of. In terms of, again, just unit or, what would be the smallest unit? What would I think about that again in the scope of such a web application? What is too big, kind of, in terms of, if, for example, I don't know, I wanted to register a user to a database table, and then I have my service layer, which does the registration, saves it to a database. How do I think about the units here? When is it too small, too big, and that sort of stuff?
I don't want to sound like a jerk, but the real answer to your question is moo. Unask the question. Like, for me, the important thing isn't where's the right place to draw the boundaries. Mm-hmm. For me, the real question is, what are you trying to check? And it's wise for several reasons to try to write a smaller test that allows you to check the same thing. So, for example, the naive approach could be just run the whole thing end to end because I want to check the whole workflow and I want to see if it works. So then, you
have a browser,
run everything, click in the browser, see what happens, right? This is what we used to do before we knew any better. Pretty soon you start to realize that click, click, click is boring. So you try to automate the click, click, click. But then even if you do that, I want to test some path through the controller, and I have to know when I get to the end of that path, what row is going to show up in the database at the end, even though I'm not really worried about what happens to the database. But I'm using the database as evidence that the path through the controller that I care about is the path that ran. And then on the other end, I have to know exactly which sequence of screens to go through. It's a 6-step wizard. Now I need to know that if I want to check what happens in step 4, I have to know how to go through step 1, then step 2, then step 3 to get to the correct conditions for step 4. That's boring. Like, that's pointless. It's annoying. It gets in the way. What I really want to do is just say, okay, any good fiction story drops you in the middle of the action and you sort of, as the reader, have the experience of figuring it out. Something similar happens with, let's say, more focused testing, where I'm not interested in what it takes to get to step 4 in these conditions, but can't I just go there? And that's the point at which once I, as the programmer, as I'm writing tests and I'm struggling a bit, and then I say, well, can't I just go there? That's the sign to me that all the stuff, the click, 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 is now getting in the way. So then we talk about, for example, testing under the skin. The browser stuff is just one way of accessing the logic of the application. What if we got that out of the way? All the HTTP parsing stuff, all the, worrying about whether you need to have a server running locally or whatever. Just get rid of all that. Can't I just instantiate my controller, run it, and see what happens? And that's sort of where it starts. And so I would never say to anybody anymore that they're doing it wrong. But what I would ask them is, if you're really interested in checking that, so for example, I want to make sure that my controller, if I go through this path through the controller, that I end up on the correct screen. Why in the world would I worry about what's going on? Why would I even run what's going on in the database? That's just irrelevant. Mm-hmm. And so my advice to people tends to be, try to remove irrelevant details from tests. And that tends to make your tests execute more quickly so you get the feedback quicker. But it has a more subtle effect where it puts what I call positive pressure on your design. And so if you want to just test this smaller part of the system in an isolation, and that's hard, that tells you that you have some coupling problems. It tells you exactly where the coupling problems are. It probably gives you some clues about what kind of coupling problems those are. And now you can have the interesting discussion and make the tough decision about whether to decouple there or not. And that's usually where all the arguing starts. Because then on one hand, you have people who say, but I just want to test this thing in isolation. I just want to check to make sure my controller works. I don't care about the database. I don't care about the HTTP or the HTML front end. And then on the other side, the people who say, but it's too much effort to pull things apart and to be able to run them in isolation just for testing, as though testing weren't important. Those are the fun discussions. But it starts with this idea of just simply, if you want to check this and you're forced to run this bigger part, then see if you can shrink that down. And that usually leads to better behavior.
Right. Because you've just talked about the pressure that testing puts on the system design. And then I've seen developers write online, hey, if I start writing 100,000 unit tests or the tiny tests, they just break with every refactor, and I have a huge debt. I'm just incurring a huge debt on the other hand, on the other side. What do you think about that?
Again, I'm not going to tell anybody that they're doing it wrong, but I will say that it's true. If you have to change contracts between parts of the system, then the tests are going to have to change. But if you want more of your tests to be at a bigger scope of the system, then those tests are going to be slower. You're going to need a lot more of them. And so you're not going to be able to run them as often, which means that you're not going to get the feedback as quickly as you'd like to have it. Which set of problems is right for you? I mean, only you can decide that. Would you rather, you can always delete tests. Deleting tests is always safe. If there's tests getting in the way of your refactoring, throw them away. If you're designing your components at every scale to be decoupled and talking to each other through nice abstractions, then you can always just take an entire tree, throw it away, and build it again. You don't have to save it. And this is the kind of thing that I think a lot of programmers, because they are so accustomed to letting the components of their system be tightly coupled to each other, they never get to experience the freedom of throwing an entire tree of the code away, throwing the tests away, saying, okay, now I know I have these 5 tests I want to start with. Let's try building it again. And maybe I take 4 of those old tests and start there and bring them back. Maybe I bring back 90% of what I threw away. But I have the freedom to throw it away and rewrite it from scratch if I want to. And I think this is one of those things that some people find frightening and other people find liberating. And that's just a difference maybe of, it could be a difference of experience. It could be a difference of optimism in personality. I don't know. Maybe you need to see somebody do that and survive it a few times before you believe that it won't be a problem for you.
Yeah, kind of. I mean, I think with these old legacy systems I've worked with, I mean, you usually don't even know what the test was for anymore,
Right.
and
Right.
who wrote it, and they're long gone, kind of, and you wouldn't even think about, can I throw it away? I mean, can I throw it away? Can I not? I mean,
You can always throw it away safely. The question is, whether there's any knowledge that you need to keep. Like, you don't have to run them. If you delete tests and that breaks your system, you have a bigger problem. Like, stop.
Yeah, okay,
Hit the big red button right now.
Right.
But generally speaking, when if you look at a test and you can't tell what its purpose is, I'm not really sure how it's helping you. You might be better off throwing it away than keeping it. Again, might. All of these, every single one of these bits of it, they're not advice. They're reminders that everything's a trade-off. There's no best practice. There's no one obvious way to do things. If there were, I wouldn't be here. Everything's a choice. Everything's a trade-off. Always ask yourself the question, what am I trying to do right now?
Right.
And so, so to the people who say, well, if my tests are too narrow in scope, if I have micro tests everywhere, then I run the risk of the tests interfering with my ability to refactor. I understand how you feel. There's a strange meme that's been going around for the last 10 to 15 years that people would rather have duplication than premature abstraction. And I have to say, I don't get it. To me, the only way I can make sense of it is that there are a lot of programmers out there who are afraid of refactoring their abstraction choices. They're afraid of refactoring their interfaces. And I kind of get it. I mean, the interface is supposed to be the part that's stable. It's supposed to be the part that clients can depend on. But you should be able to refactor there too. And there are ways to do it. And they're in Martin Fowler's book. I mean, none of this is new. But again, I think there's something about extracting the interface. There's something about having to write that stuff down where programmers act like now it's a law and I'm not allowed to change it. You can totally change it. And it's not that hard. It might be a little tedious. It might be a little scary, but you do it 5 times and then you can do it 100 times.
What I'd be interested in is, what about, badly written tests themselves, essentially.
Yeah.
I mean, do you ever feel that that's a problem, as opposed to, I mean, let's say the layer of how big of a unit a test spans, but then the tests themselves are kind of weirdly written and just bad, kind of from an
So it's both a problem and a solution. It's a problem in the sense that the purpose of testing is to increase confidence. And if your tests are not helping you increase confidence, then you should stop and figure out what's going on, right? It could be that you're trying very hard to follow some rules you read in a book. They're well-meaning rules by well-meaning authors in very good books, and you have to start by following the rules because how else do you learn? But if nobody helps you understand how the rules you're following connect to the problems you're trying to solve, then it's very easy to just follow the rules forever and not really know what's going on. And then not know how to make a decision in a difficult situation, such as we keep writing these tests and they look funny and nobody understands how they work and they're slow and they're long, but the book says we need them, so what do? In that sense, it's a problem. It erodes confidence instead of building it. And if your tests are reducing your confidence instead of increasing it, something wrong is happening. Please ask for help. Ask.jbrains.ca. But at the same time, it's a solution because, one of the things that when people start to practice test-driven development, the driven part in test-driven development includes that I use feedback from my tests to inform my design decisions. So if your test is longer than it needs to be, if your test seems to include a bunch of extraneous details that you don't care about, that aren't directly related to the thing that you're checking, if they are slow, these are all irrelevant details that are trying to tell you something. And they're trying to tell you that there are parts of your system which are too tightly coupled. Mm-hmm. And if you decouple them, it will be easier to inspect parts of the system independently. And that's that positive pressure that I was talking about. So on the one hand, if the tests look weird, feel weird, then programmers might lose confidence in the tests, which is the exact opposite of what we want. But at the same time, if you follow this principle that says that if my tests annoy me, then the problem must be in the production code designed somewhere. Mm-hmm. And if I then refactor my production code to make the tests nicer, generally speaking, that improves the design in other helpful ways. Like practicing test-driven development means adopting that principle. Not following it like a law, but that's the difference between, say, doing unit testing, or doing test-first programming where we just write the tests first in order to reduce defects, but then we design by drawing on paper in a nice, room with a glass of wine or whatever it is that you do that make you feel comfortable. When you go from there to test-driven development, again, part of the driven part is the tests inform my design choices. And I think it's an act of courage to look at your test, to go, bleh, I don't like that part, and then to refactor the production code to make the test nicer. Because again, there's senior programmer or architect over here saying, what are you doing? What are you doing? This is pointless rework. When you're saying, well, part of what I'm trying to do is to make the tests nicer so that we find them helpful instead of an obstacle. And by the way, if you do that, the tests get in the way of the refactoring problem starts to go away.
Mm-hmm. We'll talk a bit more about the relationship with architects and whatnot in a second. You mentioned books, rules, laws, whatever.
Yeah.
If someone today wanted to get into the whole TDD topic, do you have any book to recommend, by the way?
Yeah, this is hard because so many of the books that I care about are 25 years old. And on the one hand, I think they're timeless. I think the ideas are timeless. I think any programmer can pick up Martin Fowler's refactoring book, whether they get the new edition or the old edition. And I don't really think much has changed, except that maybe some of the bits of the Java code in the first edition will look a little out of date. But the underlying concepts still work perfectly. I don't think we've had a new evolutionary design or test-driven development book in a long time, and I just don't think we need one. Mm-hmm. So in that sense, it might be better not to start with books, but instead to just, one or two conference talks, maybe a talk about 4 stages of TDD, for example. which if I haven't published yet, I think I will soon. I mean, really, start. Like, don't worry about trying to read books and trying to do it well. Just start by trying to write the test before you write the production code and see what happens. Programmers have this tendency to want to read their way to proficiency, and it doesn't work. You have to practice. The hard part is it's hard to practice when you're on your own because you have no idea whether you're doing it well. And that's why you need to surround yourself with people who will help you and answer your questions in those moments of doubt where the rules say I should do this, but I did it and it looked weird. So then you need to go and there needs to be a place to go and ask a question. Ask.jbrains.ca. So I don't know what the modern books are. All the books that I remember that were really formative for me were all from between like 1997 and 2005. I genuinely think they still work well.
Right. You've mentioned in your latest video, in the revisited video, that you think that collaboration and contract tests would be the antidote to, I forgot what, but in any case, could you just roughly talk us through what collaboration and contract tests actually are, or what you mean by them?
Yeah, so this is what's the alternative to the integrated test? If the purpose of the integrated test is to see how parts work together, you're using an integrated test when what you want is an integration test. So again, is my focus on testing large parts of the system or on testing how two parts interact with each other? And since consultants like to make memorable things and since alliteration is memorable, I started saying collaboration and contract tests because they both start with C. And the basic idea is the collaboration test answers the question, do I talk to you correctly? And the contract test answers the question, do you do what I'm expecting? And if I talk to you correctly and you do what I'm expecting, then do we really need an integrated test to see what happens when we plug the two of us together?
Do you have one real-life example of such a...
So one of the classic examples is the point of integration between a controller and a repository. So one of the teaching examples I've been using for years is a really simplified point of sale system. And one of the early features is I scan a barcode and I should see the price of the product on the screen so that the shopper knows how much to pay me. So there's a controller which is eventually going to take the request to sell one item. It's usually how we call it. And it needs to talk to let's call it a product repository because we're in Java and that's the law. I think that's an EU regulation now.
It is. That's a good one.
And but we could call it the catalog if you want, because in 1967, if you want to know what the price of a product was, you looked it up in the catalog. But I go to the product repository and I say, I have a barcode, please give me a price. So there's a method somewhere or a function called find price. It takes a barcode and it returns a price. And so I don't want to have to I know that in the end, the catalog is probably going to be implemented maybe by a database table, an SQL database. Maybe it's a spreadsheet. I don't know. We'll figure that out later. The most important thing is I don't care. My goal at this moment is to check that my controller works correctly because, of course, maybe there is no price for a barcode, and what do I do then? Very simple test. So the collaboration tests for the controller would say, well, pretend that find price returns a price. If it does, then I should probably show it on the cash register screen somehow. So maybe that means choosing a particular view to reply with or talking directly over some interface to some LCD that's connected by USB. It doesn't matter. What's important is that path ends up with display price. So I have a test that says, if find price returns a price, then I better call display price with that price. That's a collaboration test.
Right.
I'm the controller, you're the repository, I'm talking to you correctly. But now the contract of find price is the rules of behavior that the clients can depend on. So, okay, let's pretend that we're working in Java and find price returns a price. And because it's Java, we know the price might be null. Okay, I'm going to take advantage of that and I'm going to let null represent I didn't find a price. This barcode is unfamiliar to me. I can't help you. Good luck in life. So, okay. The interface will have a method called find price. Its argument will be a string. It will return a price object or an int, however you want to do it, something that's nullable. Now, that method on its own on the interface, we call that the syntax of the contract. Like, what's the shape? If I say that I want to implement the product repository because I'm going to talk to a database, my class had better implement that interface. I'd better have a method with that signature. Otherwise, the compiler's type checker will say nope and will refuse to even run the code. That's the easy part. That's the part where there are contract tests that the compiler writes for me and runs without my permission. In JavaScript or in Ruby or in Python, we might have to write those tests ourselves. But the real fun comes when we've all had the experience where the program crashes and you find out that they threw an exception, but you expected them to return null. And that's a contract mismatch. So the purpose of the contract test is to check those kinds of rules of behavior. So I call that the semantics, which is just a fancy word. Well, it's a Latin word for meaning, right? But again, syntax and semantics, alliteration, consultants, it's memorable. That's why we do it. And so the rules of behavior are the standard set of tests that any product repository implementation must pass in order to say, I'm a product repository. Just saying that you can implement that interface because you have the correct method signature, it guarantees that when you put the pieces together, they'll fit. But it doesn't guarantee that when you put the pieces together, they'll work. Mm-hmm. And so the purpose of the contract semantics tests is if you want to call yourself a product repository, then when there is a price that matches this barcode, you'd better return it and not some random number. And when there isn't one, you'd better return null and not throw an exception. And those contract tests combined with the collaboration tests give me confidence that when the controller talks to the repository, the controller works. Like I know that if you return null, I have a test that says what happens if you return null, then I have to, beep, red LED, whatever it takes to signal there was a problem. And when you return not null, doesn't matter what the value is, I assume it's a valid price because I can't tell the difference and then I can display it on the screen. So those collaboration tests tell me that when I talk to any implementation or when I talk to a product repository, I, controller, behave correctly. But now somebody else comes along and wants to implement you so that they can talk to a database or a spreadsheet or a file. They need to pass those same two tests as contract tests so that, if there's I'm going to put some data in the spreadsheet and they see there's a matching price. It's right there. So when I ask for the barcode, I better get that price and not something else. That passes contract test number one. And then I put data in the tables and there is no matching row. And then when I search, I don't find anything. Well, instead of throwing an exception or returning some weird SQL status code, I have to figure out how to return null because that's what the contract says. So then if I do that, then I pass contract test number 2, and we can be confident that that database implementation of the product repository works. And now, when you put me controller together with that SQL implementation of the product repository, it just works. And that's the thing that makes programmers nervous. Because on the one hand, the logic is unassailable. Like when I take people through it, they're nodding their heads the whole time. And I'm saying, the good news is that if you can do it here between these two components, then you can do it everywhere between any pair of components. And then you never need an integrated test anywhere to show that things are working. Now, that's not quite true, but it's really close. And programmers, they nod their heads, and then when I tell them, see, you need almost no integrated tests at all. 99.5% of your tests can be micro tests that run entirely in memory. You just need some collaboration and contract tests in the right places, and everything will be fine. And then they get pain in their chest because it sounds right and it feels wrong. Mm-hmm. Because they've been taught that the only right tests are tests that run end-to-end, or they've been taught that they can't do it well enough, and therefore they have to have some other way of covering their back. And part of what I'm trying to do in teaching these ideas of collaboration and contract tests is to not only to help them have quicker tests and faster feedback and positive pressure on their design, but I get nervous when a programmer agrees logically but their gut still says no. Like that tells me there's a deeper problem to go and take a look at. And, I want you to have confidence in things that are logically sound. I don't want you to feel fear when it sounds right.
Right. It makes sense.
Yeah.
I mean,
you don't have to live like that, man. Yeah. If it sounds right, it's probably okay. Right. And yeah, there are some things that we can do to fill in the gaps, but I want to help people get away from the idea that, if I try to put two components together and all the tests for this component pass and all the tests for this component pass, but there's still a bug, okay, there's a missing contract test, or there's a missing collaboration test, or there's contract tests and collaboration tests that don't agree with each other. One of them makes a certain assumption and the other one makes a different one. And yeah, we have to fix that. But you don't have to solve that problem by doing the equivalent of standing 2 meters back from the wall and throwing paint at the wall, hoping to paint the wall. Like, go up with a brush and paint.
Right.
And that's what collaboration and contract tests are. It's the ability to go up to the wall and paint the corners with a brush instead of just throwing a bunch of tests against the wall and hoping that it happens to work.
Right. I had a colleague of mine ask me actually, when they heard collaboration contract tests, they actually also they thought about, hey, does it have to do with, let's say, microservices and, many different teams organizationally, even building different things and not being really in sync? And then does that mean formal contracts between them? How does that whole scenario change, by the way, in that respect, if you have an entire company go crazy with 1,000 microservices? Right.
So one of the funny things, I just spent a couple of weeks at Code Camp Romania, 1 week in Iași, 1 week in Brașov, and Kevlin Henney gave a talk about his title was Modular Monoliths and Other Facepalms. Mm-hmm. Okay. So Kevlin chooses intentionally provocative titles. The first 5 minutes of every talk that I watch of his, I assume I'm going to disagree with him. And then when I know what he's talking about, I'm starting to nod my head. And his whole idea was that, or part of his thesis is, the reason that people want modular monoliths is that they think that the problem with their microservices will go away if they try to make a modular monolith. But the problem is that they're doing the monolith part, but not the modular part. And so I find it funny that this term modular monolith exists because I named it the other way. I talk about what I do as microservices in a single process.
Right. Okay.
Most people, when they think microservices, they say the microservices part, but they say the distributed part in their head because they've been trained to believe that all microservices should be distributed. Just like somehow API came to mean HTTP API instead of what it meant for decades before that, which is application programming interface, which could be all in the same process. An interface, a Java interface is an API. Anyway, when you decouple components from each other and use this collaboration and contract test approach to test them, what you're left with is microservices in a single process. And if you do that well, then it should be relatively easy, maybe tedious, to then take some of those microservices and move them into another process and maybe put a network boundary in between them. Like part of the reason that people struggle with microservices is it's that they're not modular. They're dependent on each other in ways that are not clear. And it's exactly the same problem that leads people to say, well, I don't want to decouple my components too much because then when I refactor, I have to change everything. That's another sign. Like if you have that problem, then no wonder you hate distributed microservices because it's the same problem, the same symptom, the same underlying problem with different symptoms in both cases. When you move in the direction of these decoupled components talking to each other over well-defined interfaces with well-understood contracts, maybe using collaboration and contract tests as your primary testing strategy, distributing your microservices now becomes almost a free option. Like it's annoying and it's tedious, but it's not hard. And it's also a lot safer. So one of the early use cases for collaboration and contract tests, before we call them that, when we mostly talked about interaction testing and mock objects, was exactly the one you described. We want to parallelize the work. We have two groups. Let's have one group build the client and one group build the supplier. That works best if there's a well-understood contract in between. It probably works even better if the client owns the decisions for what goes into the interface. This is the consumer-driven contract stuff that if I had known to put consumer-driven in front of contract testing, or if I had been Martin Fowler, people, I guess, would have listened to me instead of him. But it's the same idea that when in doubt, contracts work best when the clients own them. And if you do that, then it becomes a lot easier to split the work between groups, and the contract then becomes the sort of unit of stability between those two groups. Otherwise, you have the same integration hell that we've had for decades, where everyone tries to do their own thing, and then at the end, when you try to put it all together, all the wires are hanging out. They don't quite match each other. He's returning null and she's expecting an exception, all that kind of stuff. The contract doesn't need to be formal in the sense of like a legal document, but it needs to be formal in the sense that the tests are the formalization of the contract. They're examples of what it means, because now that we have two groups or two individuals sharing the work, now we have a communication gap. We need to make sure that the picture in my head and the picture of your head of what's in between us is as narrowly close to each other as possible. And having examples of the semantics of a contract seems like overkill until I tell them, well, if you feel like that's overkill, then you have to use the advanced practice of talking to each other. And then programmers go, whoa, I don't want to talk to anybody. So as soon as, if you're not going to talk to each other, then you have to write things down. It's no good to anyone in your head, Mozart. So then you do need something, examples which help communicate. When we say find price behaves like this, it's not just a sentence that can be interpreted three ways, but here are examples that show that the assumptions I make about how you're going to behave are safe to make, and that you understand the responsibility for which parts of your implementation need to remain stable and which parts are free to change. It sounds to me, again, liberating, but to some other people it sounds, I don't know, overly formal or, we should be able to trust each other, man. Okay, well then talk to each other. No, I don't want to talk to each other. Well, I'm sorry, you can't have it both ways. Mm-hmm. If you use collaboration and contract tests as your sort of primary testing strategy, that tends to shove you pretty aggressively in the direction of microservices in a single process. And now you have the option to split work among multiple groups, to move some of those services outside of the process into other processes, and you won't have the same kinds of dependency problems that you only discover as you get closer to trying to deploy things, or as you get closer to trying to release features. Then you realize, oh my God, like we decoupled structurally. But this service now fires a message to that service and has to wait for an answer. Why did you separate them? Mm-hmm. If you tried to write collaboration and contract tests, you would have realized there's way too many mock objects in this test. This is dumb. Okay, let's refactor. Let's draw the boundaries differently, when it's really easy to refactor everything because everything runs in a single process. There's a single repository, and I don't need approvals. Mm-hmm. And that's the thing that I find is the thing that I find a little bit sad about this whole thing. And that's that these are very old ideas. Programming to interfaces has been around since the late 50s. This idea of microservices in a single process, I only call it that because that's an interesting name to people who write software in sort of the 2010s and 2020s. But the ideas are so old, and we still don't do them. And the reasons we don't do them, on the one hand, they're perfectly rational and reasonable, and on the other hand, they're just so stupid. And it's like it's proof that we evolved, because if somebody had created us, I would hope they wouldn't make us this stupid. But we can't help it. This is how humans are. So we just have to figure out how to muddle along and help each other out to feel more confidence to try to do this thing that I'm pretty sure works well. But it just, it looks scary.
What I've just been wondering while we've been talking is, I feel like we're also constantly lost in translation. Maybe lost in translation is the wrong word, because as you said, I mean, you spent a while, explaining the differences between integrated tests, integration tests. Then we had, modular monoliths and the microservices in one process. And when people hear about it, I guess because, as you said, they think distributed. And then, we spend so much time debating words and phrases.
Yep.
And I don't know a proper way around that, to be honest.
So I know a really bad way around it. And a really bad way around it is to argue about terms and to say that my definition is correct and yours is wrong.
Which is what happens all the time.
Right. How many times have you watched especially senior programmers in meetings screaming at each other about the meanings of words? Because, I mean, it seems pretty reasonable, right? Can't you just talk like me, damn it? Just use my definitions and I will understand and everything will be wonderful. And that's actually one of the things that I've really learned over the last, 15 years or so, as I've been trying to train myself out of being so blamey about things. One of the consequences of that is I try no longer to think of my definitions as the correct ones. I try not to worry so much about if we can just find the correct universal standard definitions of words, then we can yell at the people who mean things differently, point to the words in the standard document or whatever and say, no, this is the one true meaning and you need to mean this, otherwise you're talking nonsense. That just doesn't work. It feels like it should, and it doesn't. Sorry. So what's your objective? Do you, I use this phrase a lot in my work. Do you want to be right or do you want to solve the problem? Because if you just want to be right, we can assume that your definitions are the only ones that matter. Everyone else is wrong. And if they would only listen to you, the world would be fantastic. But I'm not sure how much you're going to get done. Is the project small enough for you to do on your own? Probably not. So if you need to work with other people, you need to be able to negotiate with each other about what you mean, which is why I started really emphasizing this is what I mean when I say, as opposed to that's not what those words mean. I still not perfect. I still, in moments of weakness and stress, will go, but damn it, that's not what those words mean. And I try very hard not to, but it comes out because I'm trying so hard to have a conversation with you and it's not going well because the picture in my head is only 92% the same as the picture in your head, and that 8% is where all the problem is coming. So then I really want to emphasize, whenever we have disagreement about the meanings of words, that probably means that we have a slightly different picture in our own head about which problem we're solving.
Absolutely.
And if we talk more about what the problem is and get those images closer together, the rest is easy. And then if you want to call them integration tests and be wrong, that's cool. I'm going to call them integrated tests because I know that's what you mean. Or maybe even better, when I'm working with you and I know that you call them integration tests, even though that's not as accurate as it could be, I'm happy to call them integration tests when I work with you. Because then at least when we say those words, we agree on the picture in both our heads is the same. And to me, that's really the part that matters the most. And if I can nudge you towards calling them integrated tests eventually, that'd be great. But it's really not that important to me.
What kind of pains me a bit is that I think that code at the end of the day kind of speaks in terms of it's really helpful to have some code examples.
Yes.
To kind of digest and look at and align, on words. And then I thought about, hey, could we have a laptop here and pull it off? And then we tried it once a couple of weeks ago, and it needs a lot more preparation from both. I mean, from the host and the guest. And then I thought, it's probably be tricky to pull it off nicely. Actually, I would have loved now to have some proper, code samples here so we can, give some proper wording. But maybe we're going to do that next time.
Yeah, that's absolutely. And it's that's actually one of the reasons why one of the techniques that I use when I work with groups is we play a little game called "What's Not to Like About This Code,"
right?
Where we put some code on the wall, and we keep asking the question. What's not to like about this code? And somebody starts, they point to something and they go, bleh, and they describe what they don't like. And we part of the point of this game is to encourage programmers to articulate what they don't like about code so that you can learn what do they look for? What do they care about? What are they likely to argue about? And what are they less likely to argue about? What are some things that I can do to indulge their preferences? What is the difference between what's actually better or worse and what's merely I prefer this or I don't? And getting all that out on the table so that when we are in a stressful moment where we're trying to write code together to make something work and I want to do it this way and you want to do it that way, we fight less. And that's, again, part of this, like, I could just keep clinging to my way is right and your way is wrong, but I don't think that's going to get us very far. Instead, okay, can we talk more about what is it we're really trying to achieve here?
Right.
And then the solutions tend to propose themselves.
Right. I've seen you actually talk about, by the way, that you said you'd like people to overdo tests while learning. Is that the case? So to swing the pendulum kind of back in the other direction from not testing enough to kind of now...
Yeah, I mean, it's you only discover where the edge of the cliff is by falling over a few times.
Right.
And the good news is that, yes, programmers feel constant pressure to invest perfectly in these things. There's all trade-offs everywhere. Again, there's no best practice. There's no right way to do things. We never know how much testing is enough. I've never seen a better tool for deciding how much testing is enough than to use the feeling of anxiety as usually embodied by the pain in your chest. I'm not trying to encourage heart attacks, believe me, but as objective as people, especially project managers or senior technical leaders or architects, would like to be about this, we don't know how to do that, I'm sorry. And the best we can do is develop that sense of, let's call it, helpful anxiety. Just enough to tell us that, my confidence level is low, we need more tests, or my confidence level is high enough, this is good enough for now. Like if I could put that in a spreadsheet, I would have millions and millions of currency units, whichever currency unit you want. Maybe not Icelandic kroner, but but we don't know how to do that. So the best thing we can really rely on is I need to overdo it with tests in order to figure out what's boring, in order to figure out what's tedious, what's too much. And then I can trust my judgment more to write fewer of this type, to focus my energy on that instead of this. It's part of that whole thing I mentioned a while ago that, programmers want to read their way to proficiency. I don't think you can. You have to practice. And if you're not willing to be wrong, that's not practice. That's performing. Performing is great,
right?
But why is it that almost every other performer in the universe rehearses and we don't?
Right. That's a good point.
Yeah,
that's a good point. And by the way, on that topic, I think you also mentioned in one of your videos that teams need to be allowed to do silly things and do that practice kind of. On the other hand, just from real life, I mean, how would I balance, the training, the practicing, the drilling, so to speak, the silly things with all the other stuff, which is deadlines, pressure, delivery demands, your boss screaming at you, your PM boss screaming at you. How would I actually go about balancing that in a corporate environment?
This is where my thinking has really changed a lot in 20 years, because 20 years ago, I think I was very firmly on the side of the very resolute senior programmer who is very clear about their opinions and will say things like, well, you can always quit. You need to stand up for yourself. You need to be professional. You need to demand trust. I don't know that demanding trust works, and I don't know that quitting is really the answer.
Have you ever seen someone quit, by the way?
Oh, yeah. I've quit. I've seen people quit. I've encouraged people to quit, both good and bad, as in, I really stand by that decision now, or I regret that decision now. But really for me, I think that, we need to both be clear about what we are trying to achieve, and be prepared to understand the limits of what we can influence. And one of the things that has really changed is that this is not just about programmers, but programmers tend to be of this type on average, that they tend to feel responsible for the consequences of decisions that were made by other people. Because they're constantly under pressure, they internalize that pressure as responsibility. And I'm going to sound a little parental here, and I apologize, because they don't know any better, because nobody has told them that they don't have to be responsible for that. They just assume. right? And that could come from childhood. That could come from the transition between being a student and becoming a professional and dealing with other people's expectations in a way that they hadn't had to deal with them before. And if someone puts expectations on you and you don't know any better, then you're probably going to take it for granted that you should try to meet them. But at the same time, take the impatient customer. Now that could be an actual customer. It could be a product manager, project manager, senior programmer, whatever. Let's all call them customer for now. We have a tendency to see the impatient customer as a problem because they're always asking for more than we can deliver. They're always giving us deadlines. They're always putting pressure on us to deliver. Oh, we need to figure out how to get rid of this impatient customer. So you can either try to meet all their demands, which won't work because if you come in under budget, then you know your budget will be smaller next time. If you deliver to the customer, then the customer will ask for more next time. And again, many people act like this is a problem to solve. I don't think it is. I think it's a reality to accept. Mm-hmm. And that the presence of the impatient customer is the only reason that you can call what you're doing a business. Right. If you don't have an impatient customer, that's called a hobby.
Right.
Hobbies are wonderful, but I don't think you should expect to be paid a good salary for a hobby. And so the impatient customer is just a normal part of what it's like. And by the way, it's the same on both sides of the relationship. As the programmer, I can train myself to be more compassionate of the impatient customer and to remember that just because they're asking for more doesn't mean we have to give it to them. Their job is always to ask for more. Wow. Now, the trick is to try to earn their trust so that they believe that you are trying your best. They believe that you're doing everything in your power to be responsible, to deliver features at a sustainable pace. But it's the same on the other side, right? The customer has to understand that just because I'm asking for it doesn't mean I'm going to get it. And just because I'm asking for it doesn't mean I should even expect to get it. That I'm always asking for more because that's my job. Mm. And that, indefinitely sustained growth is called cancer. Like that's not good. So recognizing for myself as the customer that I feel pressure to put pressure on them. I have a natural human tendency to ask for more because that's how humans work. But just because the thought comes to my mind, that doesn't mean I have to believe it. And so there's something really magical that happens when the people on both sides of that interaction understand that the system is putting them in a position to appear like they're adversaries to each other, but they're not. And this is an article that I wrote years ago called the eternal struggle between the programmer and the business, where my goal is to help both sides of that conversation understand that they're not against each other, but the system has put them against each other. And I don't mean that in the way like,
sure,
but I just mean like that's, my job is to try to balance what I can deliver now with what we can deliver for the next year. And your job is to ask me for more. And if you stopped asking me for more, then there would be no reason for me to do what I'm doing. So like we're in this together. And I think that when the reason it looks adversarial is because the customer doesn't know what the programmer is doing. They can't see it. They can't control it. They can't be sure that the programmer is trying their hardest, right? And that's hard. When I'm not getting what I'm asking for, I don't know how to do anything more than ask harder and ask louder. Okay, but how do we build trust in a way that everyone understands that we're all on the same page? And that's when I like to, when the customer is saying, go faster, I need more features. And the programmer is saying, we need to slow down because if we don't, everything's going to stop in 3 months or 6 months or a year. They sound like they're on opposite sides of the table, and they're really not. They just have different ideas about what it takes to achieve their goal. If we make them more aware of their shared goal, which is sustained production over a longer period of time, then the solutions become easier to take. Or the opposite happens. at some point, somebody has the courage to kind of look around and go, okay, it actually doesn't matter if this project lasts more than 3 months because we're all going to be gone anyway, or we're going to throw it away anyway. And look, if that's the truth, if the truth is that there's no need to sustain our production past 3 months, I can respect that. Like, I'm willing to throw all the refactoring stuff out of the way and forget about all that stuff if our goal is really just to sprint to a finish line that's 3 months away. Two things. Thing number one, you better not try to blame me when we get to 3 months from now, because if you do, we're going to have a conversation. And two, if you're leaving 3 months from now so that it's not your problem, it's somebody else's problem, cool. You need to warn me so that I can leave 2 weeks earlier. And I think that if we can be more frank about what we're actually trying to do, then those problems actually kind of go away. We can at least navigate them together instead of the programmers feeling over-responsible for the decisions that they absolutely have no control over. And part of what I try to do is to help programmers refuse to feel responsible. That doesn't mean you don't try. That doesn't mean that you don't try to make things better. But, you know, if your friend insists on lighting his money on fire, you're not responsible for stopping them, and you don't have to watch him.
But at the end of the day, if I'm like a junior developer now in a big mega corporation at the moment right now, and I feel the pressure, what practical, pragmatic choices do I have? What do I do?
Well, one thing that every junior programmer needs to do as soon as possible is miss a deadline. Because that's part of how you learn that the deadline is usually an empty threat. Now, some deadlines are real, but a lot of deadlines are empty threats. And I promise I don't mean this in a belligerent way. What I mean is one of the big problems with corporate culture at a large scale is we're holding on to this ludicrous idea that threatening each other with deadlines is a way that we can motivate people. You asked about books earlier, and I had to make the admission that all the best books that I know are a quarter century old, and therefore maybe a modern audience wouldn't appreciate them. But go look at Peopleware. Peopleware is from the late 90s. And in there is a chapter about deadline pressure. And they ran a very informal experiment, right? One group was reminded of the deadline frequently, one group was reminded of the deadline occasionally, and one group was told, wake us when you're done. Which group do you think finished first? So we cling to this idea that exerting deadline pressure helps. Even though we have mounting evidence over decades of practice, and even now neuroscientific evidence, that it doesn't work. It does nothing. And so on the one hand, I encourage the junior programmer to miss a deadline early so that they can experience that actually it's not that bad, that many deadlines are expressions of fear, and that you can learn to have compassion for the people who are afraid that you're going too slow, so that maybe you can start trying to work with them. Now, that said, what's the junior programmer's pragmatic choice? So again, one of them is miss a deadline and notice that it's actually not the end of the world. Another is to start practicing the most powerful phrase in the English language, translate for your language at home, which is, I'm sorry, I don't know how to do that. And if you can deliver the phrase, I'm sorry, I don't know how to do that, and then shut up. And mean it. Deliver it the way I did now. I'm sorry, I don't know how to do that. And not sound blaming, not sound passive-aggressive, but to sound like you're genuinely apologetic. Not because I take responsibility for the fact that I don't know how to do that, but here we are right now, you're asking me for something, you're maybe even yelling it, you're afraid, I get it. I'm sorry, I don't know how to do that. I wish somebody were sitting in this chair right now who knew how to do that, because I want to help you, but I can't. And it's absolutely frightening, especially when you are new and you don't feel confident in your job security. You don't know the corporate world very well. You've only been at it for a year or 2 years. It's very hard to be that vulnerable and say, I'm sorry, I don't know how to do that, because you're probably afraid they're going to fire you. So here's another thing. They're probably not going to fire you. They need you more than you need them. Like, if they're going to fire you, it's not because you can't do it. They're going to fire you because somebody slashed their budget and you happen to be at the bottom of the list. So if you can deliver that line and say, I'm sorry, I don't know how to do that, and mean it, mean both that you're sorry and that you don't know how to do it. Like, don't use it to try to fight back. You have to both not be able to do it and genuinely feel sorry. There's something that happens that the other person might be a sociopath. It happens. But generally speaking, the other person realizes that you're not lying to them. And there's something that happens. You might not even notice a change in their facial expression, but sometimes you do. You see something happen in their eyes and they realize, oh my God, I can't control them. And that moment when they realize they can't, I can't control this person, at least not in this way. Part of them probably feels afraid. And with any luck, part of them also realizes, oh great, I can't control them. I should stop trying. Maybe we can work together to find some solutions. Now, again, the person who has been with the company for 6 weeks might not feel comfortable employing this strategy. But, a year or two in, at some point, you can't do what they're asking you to do. I literally had someone in one of my workshops who felt guilty because they asked me about estimating more accurately. And they felt guilt because when they were wrong about how long a task would take, then they had to work overtime to make up for it. And that's a perfect example of taking responsibility for something that is not your responsibility. We can argue about that later, ask.jbrains.ca. Nobody should have to feel like that, much less a junior programmer who is just trying their best, who should be expected to not know everything, who should be expected to be failing a lot, who should be expected to be learning. If you're hiring a junior programmer and you're not prepared to invest in their future, then what are you doing? Hire a contractor instead. Don't be stupid. So if you're going to hire a junior programmer, you ought to be prepared to invest a little bit in their future. And that means that they have to have the freedom to not be able to do what you're asking them to do. And just as humans, it works a lot better if we are free to tell each other, I'm sorry, I don't know how to do that. What would you like to do now? Can we have a conversation about the next best plan? On the other side of that, as far as like practical, find out why everyone's talking about mindfulness meditation, because man, does it help.
Right.
And I don't want to turn this into a cult. I don't want to turn this into a religious discussion. None of that. But I'm telling you that for a lot of people, some form of meditation
works.
It helps them create space between the moment where they feel an impulse and they actually react. And if you can make that space longer, then you have more opportunity to choose how to react in a way that's going to help instead of reacting in a way that's going to make the situation worse. And again, nobody is asking you, I am certainly not asking anyone to change their belief systems. If you prefer to call it prayer over meditation, you're not going to hurt my feelings. I get paid the same. But I have found that certain kinds of meditation have at least allowed me to slow down my reaction time. Not because I want to be a better person, although that would be nice. I would love you to have the freedom on occasion to lose your mind in my presence. And I don't feel like I have to punish you for it. Because if we can do that, can you imagine how powerful a trust-building moment that is?
Right.
And that's whether that's programmers arguing about how much to refactor, architects arguing about whether this way of designing things is going to work, senior programmers arguing with stakeholders about how soon features are going to be done, like all of that. We can help all of that by individual people widening the time between the impulse and the reaction. One of the ways that I learned it from Jerry Weinberg, and I think inspired by the work of Virginia Satir, is the law of three interpretations. So when somebody behaves a certain way, you start telling yourself a story about what happened. And if you can't tell yourself three different stories to explain their behavior, you're not ready to react. Now, in the moment, you probably have to react anyway.
Right.
But When the interaction is over and everyone's had a chance to go to their respective corners, you sit down maybe with coffee, maybe with something with some alcohol in it if that's what you're into, and you get a chance to sit. You cry a little, you yell a little, maybe somebody can be there to comfort you, and then you can play back your memory of the interaction in your head. And of course, you're probably thinking, why are they like this and what's wrong with them? Sit down and think about 3 different ways to explain their behavior. If you can't come up with 3, you're not thinking about it hard enough. And then to ask the other magic question, which is what would have to be true for me to behave like that? And if you can't come up with one of those, again, you're not trying hard enough. Sit down, if it takes an hour, if it takes 2 hours, and think about, let it go over in your mind. What would have to be true for me to behave like that? And once you can connect with that, I mean, that doesn't magically make them right. But again, how great would it be for our relationship if, from time to time, you were able to lose your mind in my presence and it's okay. It's recoverable. Let's not do it every day, please.
Sure, yeah. But
let's try as hard as we can. But it's so much better when you can do it and it will be okay. That buzzword psychological safety that's become more popular over the last 10 years, like that's where it starts.
Let us know down in the comments how psychologically safe you feel, actually. I'd like to hear some experience reports,
Me too.
Real life experience reports.
In my group, the JBrains Experience, when we talk about this kind of stuff, often I'm trying to help technical leaders feel less guilty about what's going on around them when it's in fact not their fault. And they feel guilt because they don't feel safe to say what's actually going on. They're worried that if they try to tell the truth, if they're too vulnerable, they'll be punished.
Right.
And that's the essence of psychological safety. Yeah. So it doesn't necessarily have to be like, I can say anything I want and nobody harms me, but more like, who are the people that you feel safe talking to about these kinds of things at work? Even if it's just joking. It was like, deadline. That's actually why it's good for the junior programmers to miss a couple of deadlines and then realize, oh, this actually doesn't have to mean anything.
We talked a lot about people, trust, relationships. AI. Let's talk about AI a tiny bit.
Absolutely.
The opposite, the polar opposite.
Yes.
Essentially. Have you been doing tons of AI programming lately?
Tons, no. But I did get a chance. One of my JBrains Experience clients has decided that I'm not good enough at marketing, and she's trying to help me. And one of the ways that manifested was we did a little video series where we built a mobile app together. She has experience in mobile app development. I don't. My experience is 20 years old, so I don't know what the cool kids are doing these days. But she thought, well, wouldn't it be interesting to try to use one of these LLM systems to build an app? Because that seems to be one of the things they're quite good at, which is building something small from nothing when maybe you want to try out a technology you're not familiar with. So this way I can get something working, and it provides me a way to get something that I can start using, and then I can take time to sit and read the code and understand what's going on. And that paired with some documentation is a nicer way to learn than trying to read someone else's tutorial when, frankly, most projects don't write tutorials very well. And so we just recorded ourselves doing this. She's gently nudging me to remember, no, use Bolt to do everything. Don't even there were a couple of moments where I had the impulse to go in and start changing code on my own. She's like, nope, try to make Bolt do it.
Right.
And what I really liked about that experience was that sometimes Bolt did some things that I didn't ask for, but were actually handy, but not always. They seem to act like really overeager junior programmers who don't always listen.
Yes, sir.
Exactly. They will tell you how smart you are and how good your decisions are. They will throw a little bit extra in, hoping to impress you. And then they will occasionally get some things wrong. And that experience has actually been quite good. But I already see a lot of the risks associated with turning over control to the LLMs with regard to your code base. And that's why I think the sort of, getting a new project up and running to the point where you can start adding features on your own, even in unfamiliar technologies, as a way of learning them, I think is really cool. Like imagine that you could generate a tutorial for an unfamiliar technology, but using a project you care about instead of a project that the tutorial writer cares about. Yeah. That's much more compelling. But it doesn't surprise me that a lot of the people that I've read articles from or seen videos of are using strategies like test-first programming, test-driven development, evolutionary architecture, incremental delivery of features or incrementally adding behavior as self-defense mechanisms against the LLMs running off and trying to do too much too quickly and generating a bunch of code that we can't trust. So it doesn't surprise me that we're using tests as a way to build trust with the code that the LLMs are writing on our behalf, that we are trying to push them in the direction of smaller steps, clearer steps, checking along the way. I don't know how much of that is confirmation bias, to be frank, because if a TDD practitioner with 20 years of experience works with an LLM, they're probably going to want to do TDD, and they're going to have the impulse to try to make the LLM do TDD because that's what made them successful. So that's confirmation bias, survivorship bias, or a good idea. I can't tell. But a lot of people are noticing, even the ones like, this might be the thing that makes a lot of people start taking evolutionary design seriously because it's a self-defense mechanism. It's an intentional bottleneck. I'm going to make this LLM generate just enough code to be helpful and not enough code to bury me and make me lose confidence. And things like, I'm going to start with some tests, please make them pass, or doing really aggressive decomposition based on 20 years or 15 years of experience of, like, I can write the tests in my head and I can get a sense for, here's an incremental path through this feature. Now I'm going to ask the LLM to do it in these 7 steps. It doesn't surprise me that a lot of people are noticing that that's helpful. I would really like to just hit the fast forward button for about 3 to 5 years, find out how actually people are using these tools for good instead of ill, and then try to figure out if I have a place in that world or not. Because the one thing that really worries me is if programmers are too productive, and let's forget about the difference between productive and effective, but if programmers are too productive, and if their primary interaction is with a machine, no matter how good that interaction is, they are not practicing interacting with each other. And when they do need to interact with each other, it's going to go less well, not more. I don't think a bunch of programmers who spend 85% of their time talking to Claude and only 15% of their time talking to each other, I don't think that's a recipe for better relationships. I think that's a recipe for more anxiety, more wall building. Are we really prepared to reach the point where programmers can work perfectly independently and build systems and they never have to talk to each other? I don't think so. If that's really the world we're going to end up in, then maybe I'm a dinosaur and it doesn't matter. But I have the distinct impression that no matter what we do, people are going to still need to talk to each other. And they're only going to get worse at it. And then they need people like me who care about that more than they care about the technology.
That's a nice point.
Metropolis, the film, the Fritz Lang film, is going to have its 100th anniversary pretty soon. And the message of that film was, between the mediator between the head and the hands is the heart. It wouldn't surprise me if that became a really important theme in software development, just in time for that 100th anniversary.
Yeah, let's see. We'll find out. We'll find out sooner or later. What happened to the app, by the way?
I use it. It's
you use it?
Yeah,
Okay.
I use it. It has a couple of bugs that annoy me, but they're not. They're like little UI bugs that I can I can ignore them. It's an app that I use for a particular practice drill for my bowling career, and this is a practice drill I do quite often, and I'm able to track information and then export them and import them into spreadsheets and do all kinds of analysis and figure out how to improve as a bowler. So, mission accomplished. It worked well. It has a couple of defects that are minor and not worth fixing. And now I understand it even better from the customer's point of view. Like, here are some bugs that would be really easy to fix, but I'm not going to bother. And I'm certainly not going to waste my time I'm not going to waste tokens trying to convince Bull to do it.
Right, got it. I've got a bit of a tricky question because I'm going to ask you to condense your entire knowledge, consulting and testing knowledge, into a couple of, let's say sentences and key highlights. But
okay.
If you walked into any random modern engineering team today,
Yeah.
and for the sake of this argument, I don't know, again, Spring Boot, Postgres, some just a regular Java stack in that case, and you didn't know anything else about them, is there any, how would you design their testing? What would you tell them to have as some sort of a testing strategy, or how to go about that testing?
Well, so it depends. That's a real consultant answer. Am I trying as quickly as possible to make them behave a little bit better and then letting them figure it out on their own? Or am I working with them to figure out a strategy that's going to help them?
Maybe the first.
Okay. In that case, write any tests you want, as many as you want, as much as you want, any way you can. And the old phrase is test until fear transforms into boredom. That's enough. Like literally, that's really all you need to do. At some point, and then of course, if I say that, that's true but useless. Like it will help them get started. But at some point, they're going to start arguing with each other about whether they're doing it right. And so I want to prepare them for the first set of arguments. Okay. The test should always be giving you more confidence that the code works the way you expect. That the code does what you think you asked it to do, or at least the code does what you intended to make it do when you sat down to write code, right? These are the programmer tests that I'm talking about. If the tests are not increasing your confidence, write fewer of them. Look for other ways. When you feel less confidence, more fear, try to write more tests. And when you feel like the tests you're writing are weird, then look for details in the tests that aren't directly related to the thing you're checking and try to get rid of them any way you can. And that's literally enough to get started. Like that's sort of the textbook reductionist answer. Like if you wanted to, ironic, if you wanted to do machine learning, those would be the constraints that you would give the machine and let it figure out all the details. And it would probably write some of the early books on extreme programming. That's my guess. Or we might have an AlphaGo moment and it might actually figure out that there's a completely new way to play the game that no human thought of. But probably that's what it would do. What I find really important in that situation is they are probably going to want to do things perfectly. And even if not, they're deeply concerned with doing things well. They are afraid to make mistakes. And yeah, we can tell them, but learning requires mistakes, but that doesn't help them. Like again, true but useless. I have learned through practice that the primary way I can help in that moment is to tell them that doing it well is not important, that what's important is reducing the resistance to trying. Whatever is going to make you feel resistance to try, let's attack that. And sometimes that means helping people feel permission to do things just kind of 65% well. And again, it's a platitude to tell them that, it's better than nothing. But really, if we need to sit down and have an hour-long conversation on the ways in which their brains are broken and like every other human brain is broken, and just because you have the thoughts doesn't mean you have to believe them, we can do that. But in the end, I find that if I tell them up front that what I'm trying to do is help them break down the resistance to trying rather than to figure out how to do it well, whatever it is, a lot of the time I'll notice they'll just sort of lean back a little bit, their shoulders will slump a little bit, and is that really all I have to do? Yeah, that's really all you have to do. So then with testing, then you can say, test until fear is transformed into boredom, and they can actually make use of that. Because if they get wrapped up in micro tests and unit tests and integrated tests and integration tests and end-to-end tests and system tests and programmer tests and customer tests and functional tests, pretty soon they're just going to be yelling at each other at meetings and nothing has got better. And that's not what I want for them. Right. We tried that and it didn't work.
Right. By the way, I forgot to ask you earlier, how do you feel about manual QA tests? So you have a team of manual QA testers testing the software just before release. What's your take on that?
Just before seems risky and invites failure. So I'd like them to do it earlier.
Right.
And if they are using skill and creativity to find new ways to explore what the product does, just in case we maybe don't want to do that, that's great. But if they are executing the same test plans over and over and over again, I hope somebody has a plan for automating that. Not because manual testing is wrong or bad or useless, but humans running the program and evaluating how it works seems to be more valuable when they have the freedom to try to find things that nobody has found yet, where they have an opportunity to use their time to imagine new ways that things might not be optimal, where things might not be helpful, where they can act more as agents of the users and the customers, as opposed to a human automation system for programmers who would rather write production code. And so the moment those people testing notice that they're running the same tests over and over again, 3 strikes and you automate. Like, that's not a bad principle to live by. And I hope then that somebody somewhere has reserved some capacity so that programmers can help them, if they need it, automate those tests. And then they can spend more time thinking of new and interesting ways that the system might be broken, new and interesting ways that the system might not be responding well to stress. That's actually going to be helpful.
Mm-hmm. It's kind of, actually it just reminded me of a point you made early on, because I've seen when I'm just oversimplifying, the general programmer is usually happy with the happy path, kind of they build something and then the happy path. And then you've got maybe an edge case or maybe just one error path, but that's actually always more than that. I mean, there's a couple of error paths and then edge cases even, and kind of, but then kind of motivation goes down to really test all these other tiny edge cases and paths. At least that's been my experience, kind of.
I had a different experience. So remember that I came to programmer testing, how to test Java code, because I was tired of arguing with testers. I understood intuitively the idea that we learned from theory of constraints, that the bottleneck in an approval system is rejection. That if there's an approval system, you want to give it stuff that it's going to approve. And that increases flow. So in the case of me and the tester, I want to give the tester code that they're going to be happy with, that works well enough for them. And if I learn what they're looking for, then I can check it myself. Well, guess what? Testers, on average, if they're helpful, have a tendency to think about error paths. So I realized, hey, I should probably pay attention to this. So, I found a testing heuristics cheat sheet from my, colleague, then friend, Elizabeth Hendrickson. Here are a bunch of things to try. Mess around with the code and see what happens. Here are some inputs that might fail. You should probably check those. And I became interested in that. And I spent about 6 months changing how I practice test-driven development to start with the error paths, because I was bad at it. And if you're bad at it, do it more.
Right.
So I started with the error paths, and then the happy paths were dessert. That was what I got to do when I felt like I had explored the error paths enough. Now, I honestly don't know how much of an outlier I am. Like, I don't know if you simply give programmers time to breathe, and if you find out that they already care about, in this case, I want to stop shipping bad code to the tester, I want to stop arguing with them about silly things, I'm just going to feed them code that works as much as I possibly can. If the programmer is capable of having that thought, then they are capable of turning themselves into the kind of person, or I shouldn't say the kind of person, but they are capable of maintaining their motivation beyond a couple of perfunctory error tests. But if they aren't, that's fine. Somebody needs to come up with those ideas. And if that means that we have to hand the programmers checklists and they have to pinky swear to actually follow them, then that works too. And that helps break through this persistent myth that programmers should not be allowed to test their own code.
Right.
Programmers should no single person should be trusted to test anything on their own. We should probably have at least more than one person. But I think it's silly to say that programmers are incapable of being effective testers of their code.
Oh, they certainly are. Right, which brings us to the last section, which is rapid fire questions.
Perfect, bring it.
I've already mentioned it to you before, but for the guests who are watching, for the viewers who are new to the show, what I try to do is I go to ChatGPT, I put in, hey, I have a guest coming from Canada in this case. We're talking about testing. Please combine your location of residence, Summerside in this case, with testing. Put it into 3 questions, and then, these are the questions it gives me.
All right,
so we'll just give it a go. And maybe before that, actually, before we come to rapid fire questions, we have a raffle. We give out licenses. Again, that's one question we'd like to get an answer from. And please, what would the question be that you have for the audience?
So my very first contract job after I left IBM was somebody lured me into a team with the promise of doing extreme programming, and that's how you lure me, the 27-year-old me at the time. And I stayed with that group for about a year and a half. And when the writing was on the wall and it was time to leave, on my way out, I told the person who had lured me onto the project, not only are they going to tell you to stop testing, but they're probably going to tell you to throw the tests away. I give it 2 weeks. 2 weeks late, 9 days later, I got the message. They told us not only to stop testing, but they told us to throw away the tests. How many tests did they tell us to throw away? This was a relatively small to medium-sized Java web application in the year 2003 that was trying to replace a COBOL system to manage the extended warranties for Toyota cars. So, 6 people, 18 months of work, Java web applications, 20-year-ago technology. How many tests did we have that they told us to throw away?
Cool. Good. Write it down below in the comments. All right. Now, rapid fire questions. I heard that Summerside, or at least ChatGPT heard, Summerside is famous for its lobsters.
Yes.
If your test suit were a seafood platter, which test type would be the lobster and which one's just the soggy fries?
The lobster is perfect collaboration in contract tests. And the soggy fries are the end-to-end tests that we wrote because we didn't have a choice.
You live by the ocean. What's more terrifying, a production bug or a hurricane warning?
I finally lived through my first hurricane, and I heard a crack, and I thought it was our roof, and it turned out to be a tree nearby.
Ooh.
I've never been that afraid in my life. I think I finally fell asleep out of exhaustion at 6:30 in the morning.
Right.
It was not fun. So I think I'm going to have to go with hurricane. Not even at this point, I think maybe the hurricane warning wouldn't be quite as bad because I've made it through one, but I am not eager to go through another one.
All right. Okay.
160 kilometers an hour is fast.
It is, right.
There's no reason for air to ever travel that fast on Earth.
Right. I think you've once mentioned integrated tests are like falling into a hole, or integration tests.
Yeah.
But if Summerside built a tourist attraction called the Integration Test Pit, what would visitors experience?
Ooh, I like that. They would fall into a hole, and every time they asked a question about how to get out of it, they would get a completely useless answer. And then it's like the escape room you can never get out of.
Right.
That will be €100.
Right. Right. And last but not least, if you could trade one bad testing practice for a lifetime supply of PEY potatoes, which bad testing practice are you giving up?
Well, first, keep the potatoes. But they're good quality. I'll give them to other people. I don't need that many.
Right.
I would love to get rid of the practice that says because we wrote a test, we are never allowed to delete it.
Right.
If I could wave my magic wand, every programmer would have the courage to throw away their tests and write them again if they needed to.
Right. I'll tell you what, JB, thank you very much for the podcast, for sharing your experience. Next time we have to do it again. We have to look at some code. We have to look at some code examples.
Sure.
But thank you for being here.
Thanks very much for having me. I've had a lot of fun.
Cool. Thanks.